Okay, this is take 2 of our programming part 4 lecture because the audio cut out part way. I'm checking, making sure I actually see the audio. Hopefully I'm not too loud. Okay, so let's get going with this. Let's see which one I have. Programmers pointers. Okay, I have to go over a lot of this code again just to make sure we're all on the same page. So you can watch the first part of the video. It stops at about 35 minutes in when we get to this point when I talk about memory leaks. And the point of the matter being that a memory leak is I've gotten hold of the memory from my system. I don't give it back because I don't call free, and if I don't call free, then it's mine for as long as my program is running. If I'm running something like a server, if I'm running something like a video game, if I keep on requesting memory, it's mine. I never give it back to the system, and eventually I will run out. And so 2 days later, my application crashes or the game crashes because it ran out of memory, and it's one heck of a time trying to track that thing down. It is like taking books from the library, not having an upper limit to the number of books you can take out, and eventually the library runs out of books. The metaphor breaks down at about that point. So here's some other common things. Using a pointer before it's initialized. I have a pointer. I set it. Well, what am I pointing to, right? I'm pointing to nothing right at the very beginning. You could say, why doesn't it have a default? Well, it could, but C++ as a language, because it was designed to be fast, doesn't do defaults. It doesn't do that extra step to make sure it saves you one operation. So if I make a pointer and I don't set it to something, you don't know what it's pointing to, and weird, wacky things can either occur or just doesn't. It'll actually tell you that you're trying to access a variable that has not been initialized. So you can use allocated memory before it's initialized. So here we go. I'm going to call malloc. Here we go. Here's my pointer, and then I'm going to print out whatever the first number in this array of memory is. Well, malloc is whatever the heck was in my system beforehand. There's nothing so it's some random gibberish, whatever was there before. Calloc would clean it, but malloc doesn't even clean up the values. And so I'm accessing something, whatever was left in my system, the last person to use it, I'm seeing whatever they had left behind. All the junk and the garbage. It's the worst Airbnb ever, right? You go to some place they didn't clean up at all, you're getting whatever they left you. So that's what malloc does. Calloc is a good Airbnb. Malloc, not so much. All right. There's a memory leak. Okay. So memory leaks, if I allocate memory and I don't give it back, I can lose content. I can run out of memory altogether. Other people, if I don't give it back, seg faults are going to be kind of hard with this one. A seg fault is when I try and access memory that I'm not allowed to access. If I call free and then I try, the more common thing would be me calling free on this and then trying to access something I gave back to the system. That would be normally the classic seg fault. So if I call free, I gave the memory back to the system, I still have a pointer to that memory, and then I try and access it. That's a seg fault. So I change this from a new to a malloc. New is C++, malloc is my friend, how we get memory in C. And so I'm going to here would be me creating just a wickedly bad memory leak. So every time through the loop, I'm going to call malloc each time through the loop. It's this call right down here, by the way, in case you're wondering. So every time through the loop, I'm going to call malloc. I'm going to make 50,000 integers, an array of 50,000 integers. Here's the pointer to the front of that. It's mine now. I do a out statement saying, which iteration through this loop I'm in. And, let me go back one because I accidentally clicked it. I++, okay, while P is, well, that's an infinite loop. As long as I keep on getting memory, as long as malloc keeps on working, I'm going to keep on looping. The I is increasing, but it's not stopping this while loop. I have an infinite loop here. I'm getting 50,000 element arrays each time. And then I'm changing what I'm pointing to. P was pointing originally to this chunk of memory up here. Then I'm pointing to another chunk of memory here. Then I'm pointing to another chunk of memory here. And then another chunk of memory here. Every single time I create a new chunk of memory, I didn't give it back. I just stopped pointing anything to it. it's still mine. It's I take a book from the library and then I lose the library book. It's still mine. I still have it in my possession, but I can't give it back. If I don't have any way of finding it again, it's still mine. I haven't given it back. That's a memory leak. So since I can't give it back, it's mine. I keep on leaking more and more memory until my application is fully closed. So you can pause this if you want to read an XKCD article or comic. Okay, so we also have order of operations for pointers, and this is one of those nitpicky things that I have asked questions on an exam, but that's a multiple choice kind of question. If I'm doing plus plus, or plus plus my copy versus my copy plus plus, they do different things. The plus plus is the order when that increment happens. And so the question is, if I do this pointer dereference plus plus, what is it doing? And so what actually ends up happening in this particular case is I dereference it, I get the value, and I store it in a variable. I store it into the variable, very original name, and then I increment the pointer afterwards. So it's this goes into variable, and then afterwards, when all is said and done, then I increment pointer. Why you would try and memorize this, just don't do that, essentially, is my normal philosophy. If it takes you 20 minutes to figure out what the heck the code does, you shouldn't be doing doing that particular thing. So in this case, what am I doing? I am going to dereference my copy. So we store the value of I into my copy, and then I increment my copy afterwards. That's what that one does. If I put the parentheses around this, what you should do is we obtain the point this, then we increment the pointee, what I'm pointing to. So I'm going to we obtain this value, p test, we obtain the pointee, there you go, what it's pointing to, and then we increment it. So this incremented. If I remove the parentheses, it will dereference the test, stop what it's doing, then increment the pointer itself. So if you don't believe me, we'll play with this one more time and see what we actually get from this. So we'll do some order of operations here, but let's look at what this thing does. So I'm going to get an array of 4 elements. They're all going to be set to some garbage value in here. And so this is what test is. If I dereference test and set it to 1, that means the very first element right here is going to be the value 1. Then I can print off what that value is. It is what is at position 0, I should say, at position 0, and it should be the value 1. Fine. Here I am. I'll do a dereference. I will dereference test, which does nothing, and then I will increment test, meaning I moved the test value itself will be moved over 1 position. And then, so I'm pointing to the next point. I was pointing here, now I'm pointing right here, every time. Now I'm pointing to the second part, or index 1. So now I'm pointing to index 1, okay, and then print out the value. Well, it was whatever was there before. It's a bunch of gibberish, right? None of these are initialized with malloc. I've set the first one, but then I've moved my pointer over. I'm pointing to something that has not been initialized. I get whatever gibberish was there before. Okay, next step, I'm going to set whatever I'm pointing to, I'm going to set it to 1. Okay, I'm going to set it to 1. I'm going to take whatever this is, I'm going to dereference what test is, so what's in the bucket. I'm going to increment that. It's going to go from 1 to 2. So there's now a 2 here. And then I print off a dereference test. So I print out the value 2. This and this are both printing off the exact same thing right here, the second, or the element 1 in the array. So 0, 1, element 1 in the array, but first time it wasn't set to anything, now it's set to something. There's order of operations with the plus plus. Now if I do the plus plus star test star, we can actually test this sort of thing out. So what I'm going to do, let's see if I can do this. I have some code, should have some code here. This is my old code. I actually didn't open my new thing yet. I should have done that before I started up here. So we have code quality, file IO, string test, preprocessor test. That'll do. Okay, I'm going to go down to wherever my original test thing is. And let's see what I have. So I'm going to int I is equal to 3. I'm going to make a pointer to pi for pointer to I as equal to. All right. I'm going to pi, if I do plus plus star pi, let's do that. And then I'm going to do printf. And let's find out what the heck this thing is actually going to spit out for us. And I'll put some dashes just so I know what the heck I'm printing off here is. All right, and I'm going to dereference pi. So what's in the bucket for pi? If nothing is changed at all, or wherever, if I don't know if pi is going to dereference this. I'm going to dereference that, and then I'm going to increment it first. What the heck is going on? But it's going to do something, so let's find out. Oh, and I have an extra equal sign. All right, let's see this in action. It'll break there. I'm going to go one step further. I just want to see what the heck this thing is actually going to spit out. And here we go. The value is 4. I start off with 3. It is dereferencing it, and it's going to increment whatever this thing is. It has to do that order of operations. So there's an implied parentheses in front of it. If I did it the other way around, I dereference it and then increment my pointer itself. But that's not what's happening here. It is dereference and then I'm incrementing, because I cannot increment just that star itself. The plus plus I plus plus is this does the increment before I do a bunch of other stuff. The other way around is at the very end I will increment my value. Okay, these are one of those things that I try not to get myself into those situations where I don't know what's going on with this. So just as a quick reminder, we've already done a lecture on 2D arrays, or a mini lecture on 2D arrays. So let's just do a quick reminder of what's going on with an array. For our arrays, they're very much like pointers, because in fact an array is referred to as a pointer, right? I point to the front of my array. That's how I know if there's other things. And there's no way for me to know if something is an array or a pointer, especially a dynamic array or just a pointer, because I don't know. And so I can do all the math that I was going to do beforehand. I don't know how this is actually going to. I don't know if I have a pointer or just a regular pointer, or if I have an array. And that's one of the reasons why that prefix notation, this Hungarian notation, where I put an A in the front to say, hey, by the way, this is an array. So they're very much like each other, and the pointer is equivalent to the address of the first element. Okay, so this vals, these, by the way, this is a constant pointer. This is one of the things we're going to be looking at next. The whole idea of a constant and the weird, wacky things that comes with. So here is a constant pointer. I'm not allowed to change this. I'm not allowed to change what vals points to. Why? Because otherwise I would lose this back here. I'd lose the 4, 7, and 11 here. I'm not allowed to modify where vals points. It is a pointer technically, but I'm not allowed to just like, oh yeah, I'm going to point to something else. I can modify what I'm pointing to, or what I'm looking at. So vals is at this particular address is just a pointer. If I do a cout of just the pointer, I will get the address of it. If I dereference it or put a 0 in there, I will get the first element of my pointer. Just as a quick reminder. And I could use so here I am making an array, and I could just put another pointer and point to the front of this thing, point to that 4, and it'll act and work just like an array. So here I have val pointer, it points to vals. It could also point to that this dereference for, but doesn't matter, right? This is a pointer to this array, and now I can do everything I did with it with another array with this new pointer. They are effectively identical to one another. This is something that takes a bit of getting used to, so play around with a lot of these examples just to make sure you have a feel for it. If I say, here's my val pointer, and it's equal to vals plus 2, this is pointing to this first part, and then I move it over 2 places, 1, 2. So my array is 11 and 15. That's what I have left in my array. Now, if I think there's 4 elements in my array, I can walk off the edge. I have a seg fault because I'll keep going. But effectively, it's where I'm pointing to. I move my finger 2 places over, and I'm now pointing to this element 11. And if I can keep on going in my array to 15 to what, and if there's other elements. I keep on forgetting to full screen this thing. So that's nothing that overly new here. So here I have numbers. It takes 20 numbers. I can make a pointer. I can point numbers to the pointer. I cannot do the other way around. In the original case, well, this is not going to change anything, but I cannot change what this points to. This is constant. I'm not allowed to move around what my pointer points to. I can do that with a dynamic array, but not with a static array, because otherwise I would lose the data I'm pointing to. And so with a static array, you're not allowed to move around what that data is pointing to. If you're talking a character array, you can't even do, like if you have quotes around things, I can't even do that. I can't even modify the array, let alone I can't move the pointer, nor can I actually modify the array itself. And you hit that with assignment 9, I do believe. So I'm not going to work through this one all the way through. This is just a good sort of exercise to play with, and I would like you to pause the video in a second when I talk what we're doing here. Play around with it, see if you can do it. So the exercise is this: I will have I'll make a dynamic array of different sales. I will try and find out what the total number of sales made. So this is an array of sales amounts like 4.5, 9.7, whatever the case is. I want to find out what the total is. I want to find out what the average of all these numbers are, and total the number of days of sales. Well, that's weird. I'm wondering what the number of days of sales. Oh, the number. So this is the number of sales per in a run of a day. So this is the size of this particular array, and this is the number of sales made. Oh, it's just a counter variable. So we don't need to necessarily do that. So the question is, I'm going to skip past it just to point out what I'm doing. So I would like you to think about how I would, first of all, I'm going to just enter in a bunch of sales values. You can use a scanf to enter in the sales values. We'll move on from that. We will take the average, move on from that, and then you'll say what the average was, and then afterwards you should call free. So that, ideally at the end, this is what you would get. How many days of sales do you want? And for each of the days, how much, enter the number of sales that you're going to make, like 234 and 23 cents, 534 and 34 cents. So you'll take in values per day, and at the end it'll just spit out the total sales, the average sales, and then it will free up your dynamic array. If you can do that, you're doing fairly well for the assignments. It's just more practice, but it's a small enough problem that hopefully it'll make sense for you. Okay, so let's pause the video now, have you practice that, and then we'll move on. Okay, hopefully you've practiced, but I cannot force anyone or see if anyone's practicing, so you're sort of on your honor to actually do that. We've already looked at arrays of pointers, so here is me making a two-dimensional array. There's nothing stopping me. I can make an array of arrays of pointers, whatever works, right? So here's me making this is, because pointers and arrays are one and the same essentially, because the pointer to the front of my array indicates where the array is, that when I want to make a two-dimensional array, I will make an array of pointers. So this is an array of pointers, four pointers, and for each one of those pointers I point to another array. So here's my pointer, it points to another array. Here's my another pointer, it points to an array. I make I dynamically make each one of these arrays, one after the other. I make an array of pointers, and I hook up where that pointer is pointing to for each one of those. And so when I go to my double pointer at position 2, what's that going to do? It's going to go, I'm going to go into this array, I'm going to go to position 0, 1, 2, this position 2. And then I go, and now go to index 1 in this new one. Remember, it's going to it's dereferencing the pointer, it's moving it over 1 and then dereferencing. So I'm pointing to the front here, I increment it by 1, dereference it. This whole thing would be the value 1 over here. By the way, that was done live in the last video, the one that was muted, so that's why it looks weird. Here is one of my favorite examples. If we want to talk about, because these strings here, they are just pointers to the front of an array of characters. Hearts is a pointer to an array of characters. Diamonds is a pointer to an array of characters. So char suit is an array of 4 char pointers. So it is it's an array of size 4, and each element is pointing to a char pointer. It's pointing to another string of its own. And so what would this end up doing? So each char pointer is a suit, and I can individually go to suit number 1. Oh, let's go back one. Go to suit number 1, and if I wanted to say element 6, 0, 1, 2, 3, 4, 5, 6, that D. Notice I don't have to clean up hearts, diamonds, clubs, and spades because these are constant character pointers. They are not. I did not call malloc to get those things, but I did probably, and I didn't even call malloc for this suit. I don't actually have to do a cleanup of this at all. This is not me using malloc, so I don't need to call free. This is not me using malloc, so I don't need to call free. These are static arrays. So if I want to go to suit 4, so this is a suit with 4 different strings in it. If I wanted to go to 1, 3, what would it be? It's 0, 1, suit 1, and then 3 over. 0, 1, 2, 3 over, and dereference it. It'll give me the character M if I do this. That's how you think about two-dimensional arrays. It's a lookup then a lookup, a pointer of a pointer. And if I actually looked at the code itself, this is actually what you'd see, right? Here is my pointer, here's another pointer, here's another pointer, here's another pointer, and within each of those it points to a string. So you can actually look at it in memory if you put a breakpoint. We've talked a lot about arrays, we've talked a lot about pointers, but a lot of this just requires a lot of practice. And I'll also point out, this is actually, these are just actually images I grabbed from previous instructors as well, and since they're images, we're not putting in there malloc, so you'll see references to cout and new and stuff like that. But here's the big takeaway: I have memory. That's where the computer is storing what variables we're storing. Each bit of memory has an address, a location, and space. I can point to that. I can have that address, and that points to where that memory is. So I can point to where I've stored the integer I. So all that pointer is just stores the address, and I now know how to get to a particular piece of memory. If I do an AND in the front of a variable, it means give me the address of X in this case. If I put a star in the front of it, it means go to wherever this thing is and in this case, put the value 3 into whatever this is. So originally X is equals, I don't know what the value is even. P is pointing to what X is, so it's pointing to a particular chunk of memory. And if I then say, okay, go to whatever P is pointing to, whatever X is, put in the value 3. This means that the value for X is now equal to 3. I have changed what X is, a chunk of memory I have that I can store things in, and I'm saying store the value 3 in that chunk of memory, because I'm saying go into that chunk of memory, store the value 3. Alright. I also have malloc, which I always have. This can be a variable. This 100 could be any number, including a variable. It is because I'm dynamically allocating this memory. I always use size of because I don't know how big that variable is going to be. So this will be an array of 100 characters. Every single time I just get how many, a pointer to the front of all the bytes that I'm getting, all the just raw memory, and I'm saying no, 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 it's not an array of bytes, it's an array of characters. I cast it to an array of characters, saying no, it's an array of characters. They're not just random bytes, they're characters. I could cast it to an array of integers, and then everything, all these numbers and stuff that I do would be different. And so this is a pointer to the front of this chunk of 100 bytes of memory, and each byte of memory is a character. Okay, here is me making this an array of 100 characters. Again, very much like this actually. The difference is I can't change name. I can't point it to anything else. But in both of these cases, my ability to modify this array of 100 characters, it's exactly the same. Name is a pointer to the front of this array. P5 is a pointer to a chunk of 100 characters as well. I could say go to, and I can also put a pointer and it's pointing to name. So P2, some character P2 is pointing to name, and that's going to work the same as this P5. They're both pointing to a chunk of memory. That's it. P1, on the other hand, is pointing to where this variable x is located. It's x is some chunk of memory. I normally don't need the pointer to it, but I can actually get the pointer by using the and sign. And this is our character. This is how we indicate that something is a pointer with a star. All right. So with that, I'm going to stop. Next time we're going to pick up looking at pre-compilation instructions, and that can get a little bit funky, but hopefully it'll make a lot of sense if I go slow enough. All right. Thank you very much, guys. I'll talk to you very, very shortly.